Kia ora. Welcome to part 4 of Technology and Cultural Change. Over the next couple of weeks, we'll be thinking about infrastructure and its relationship to technology. This is the first module in the second half of the course, so the approaches to technology that we're covering here will be something that you can write about in your second essay, which basically has the same format as the first one that you've just written, but asks you to choose approaches or theorists that we're covering in the second half of the course. So, what is infrastructure? At a basic level, the word indicates various systems that are required for something else to function. So when we think about infrastructure in modern societies, it refers to various essential but often unseen and underappreciated facilities that include things that range from sewers to energy grids to roads to healthcare and education systems. And all of those systems do, of course, use a vast range of technologies. But what we'll be thinking about in the course isn't a general sense of the relationship between technology and infrastructure. Instead, what we're going to be thinking about is how contemporary digital information and communication technologies depend upon vast infrastructural networks, both in terms of the assemblages of hardware, software, and standards that are needed for those devices to function, and also in terms of the complex globalized supply chains that are required to produce, maintain, transport, and manufacture these things. For example, think about your smartphone. It's designed to do a huge variety of things, including web browsing, using a search engine, engaging with social media, using locational services like Google Maps, downloading applications from an app store, streaming media from platforms like Spotify and Netflix, taking photos and videos, or just calling and texting someone. And of that list of things, only recording images and sounds doesn't require some kind of network connection to other devices. And even then, without a connection, you can't easily share the images and videos you take with anyone else. So, in order for your smartphone to function as it's been intended to, a huge amount of networked infrastructure is required in terms of hardware and software and standards. The hardware includes GPS satellites to enable locational data, the terrestrial data center, where digital data that ranges from news websites to social media platforms to online gaming servers are all stored, the planetary network of undersea and terrestrial fiber optic cables through which about 99% of internet traffic travels, infrastructure like cable landing stations and internet exchange points, and finally the cellular towers and antennae, or the wireless routers that will send digital data to your phone itself. And alongside that hardware exists various forms of software that are required for all of this to work, ranging from the operating system on the phone itself to all of the code that's involved in the applications the phone uses, or the social media platforms software, which will include the user interface, databases, often mobile and web apps, and recommendation algorithms. And finally, we come to the standards, things like the Internet Protocol and Transmission Control Protocol, the various file formats that are used by all the applications, the 3, 4, and 5G cellular broadband standards, and the various iterations of the Wi-Fi wireless networking protocols. At the same time, though, we might consider the infrastructure that's required to produce the phone in the first place. Most smartphones require about 70 of the 84 non-radioactive elements on the planet, and all of those materials need to be extracted from the Earth itself and then purified and refined before they can become components and eventually devices. And after they're manufactured, these things are sold, they're used, and then they're discarded as part of the 55 million tons of electronic waste that are generated each year. We often think of our devices as having died when they stop working, but the truth is that they often have environmental impacts that last for far longer than those devices functioned for. None of that infrastructure designs, produces, or maintains itself. A huge number of humans are involved in producing and maintaining this gargantuan socio-technical assemblage. And this is a very diverse labour force. It ranges from child labourers as young as 5 years old in the Democratic Republic of Congo, who earn just a few cents an hour for digging up cobalt out the ground, to multi-billionaire corporate executives at companies like Apple and Google. The spatial and temporal scales that are involved in contemporary digital assemblages almost defy human comprehension, precisely because the inhuman planetary scale at which they operate is really far removed from our embodied place-based functioning as human beings. Equally, though, we should acknowledge that the temporality of digital assemblages requires centuries of accumulated human knowledge production and culture in ways that are very rarely acknowledged. Thinking in these terms raises a range of political and social issues that are a long way away from many of the discussions we have about digital media and communication that focus on content or representation and identity. Thinking infrastructurally about digital media requires us to think about the inequitable labour relations that exist throughout this assemblage, the environmental impacts of the globalised extraction industries that are required for all of these things to be produced, the 55 million tonnes of toxic electronic waste that are produced each year, and the vast amount of energy that's needed to produce and power this entire system, and how this contributes to ecological crises like climate change. In terms of readings for the module, we begin with a piece from Susan Lee Starr on the ethnography of infrastructure. This has been a really influential piece in terms of how it defines infrastructure as being inherently relational. So infrastructure is understood as being a series of relationships rather than being an isolatable thing or object. While this reading isn't specifically focused on technology, media, or communication, I think it's a useful introduction to thinking about what infrastructure is, why it's important, and why it's often been ignored. We then have a couple of readings that look at software, which is one hugely important type of infrastructure that's unique to digital systems. And the first of these is a piece from the early 2000s by Alexander Galloway, who argues that in digital network systems, control is largely exercised through the production of protocols, which are published standards allowing different entities to interact with one another. Galloway contends that this allows control to exist within the kind of distributed network that's exemplified by the internet, and that this model of protocological control is key to understanding how power operates in contemporary societies. The third reading from Rob Kitchen and Martin Dodge builds on this by considering how software affects the production of space. While during the 1990s engagements with computers usually took place in specific places, like at work or in a home office with a wired internet connection running to a desktop computer, today, our mobile wireless devices operate quite differently, and in combination with the billions of smart devices that make up the Internet of Things, these technologies mediate the production of space in numerous ways, and Kitchen and Dodge describe a couple of these as either being coded spaces, where software augments space but isn't essential to how it functions, and code spaces, where the software failing means that the space itself no longer functions as intended. The next reading is Nicole Starosielski's piece, Thermocultures of Geological Media, which moves us from software to hardware, examining how the precise manipulation of heat is critical to the way that media technologies are both produced and maintained. Thinking about the production and regulation of heat means contemplating the amounts of energy that's required for all of these processes, and how the digital technologies that are often thought of as being informational or even immaterial actually have a massive environmental impact. The fifth reading we have is a chapter from Shannon Mattern's book Code in Clay, and it explores the ways that media infrastructure has long been embedded within cities. While a lot of the theorising around digital culture has tended towards ideas of placelessness and ubiquity, Mattern's work is a useful corrective to this in revealing how digital networks have particular geographies, and how new infrastructures are often situated on top or alongside older ones. The final reading that we have in this section is from Samir Bhowmick, and it focuses on lithium batteries, which are a key component of technologies that range from smartphones to laptops to electric vehicles. Bhowmick articulates a number of the social and environmental issues that exist around the production of lithium batteries, and it looks at how design strategies around planned obsolescence contribute to some of these problems. And the article finishes with quite a hopeful description of a community art project that both intervened in these issues creatively, but also sought to create a community dialogue about electronic waste and how digital technologies are impacting the planet. I hope you enjoy these readings, and I look forward to discussing them with you in our online seminars and reading about them on your course blogs.